Hello, everyone. Good morning. Welcome to our technical session T-40. As a reminder, this is a technical session pertaining to the 1002 exam, and in it, we will be going over mobile operating systems. Our objectives for this T session are to describe at a high level the similarities and differences between mobile operating systems and other operating systems, and to compare and contrast the most widely used mobile operating systems, including Android, iOS, and Windows, including their most common functions and features. Okay. Our BSMs to keep in mind for this technical session are communication. Working in IT, we're always going to need to have great communication, both amongst our peers and with our customers. And we should always employ a growth mindset. All right, always learning, always striving to be better, as we know that's something that's always gonna help us out in our IT career. Okay, so without further ado, let's get into it. All right, the rise of mobile OSs. Okay, so mobile OSs were have risen over the last 2 decades, and a lot of it is driven by consumers, by us, the people. Every time that a new OS comes out, we always want more, we want faster, we want better, we want more capabilities. So that is what pushes the evolution of our operating platforms for mobile devices. And then mobile operating systems are designed to enable the device mobility. Obviously, that's the whole point of having a mobile device. You want to be able to take it with you wherever you go. If you're going to another country, if you're going down the block to the store, if you're going to the gas station, you want to be able to take your technology with you. We want our OSs to support a smooth user experience. We want it to be easy to use, so user interface and easeability is a big sticking point there. And we want them to provide all-in-one capabilities. I think when I was going through the cohort, Kelly had a great fact that 99% of consumers do most of their computing on their mobile device. That's how powerful mobile devices have become in the last 10, 15 years, that the average consumer, they don't need a desktop, they don't need a laptop. They can do whatever they need straight on their mobile device. Desktops versus mobile OS. Can I have someone read this slide for us? Oscar, you look eager. Would you read it for me, please?
Desktop versus mobile OS. Mobile OSs differ from other OSs in multiple ways. Touchscreen interface versus a mouse and keyboard. Limited power supplied by a rechargeable battery. Limited RAM efficiency because RAM is not expandable. Supporting both cellular and Wi-Fi communication, and connectivity protocols other than Ethernet.
Thank you very much, Oscar. So basically, we're going to go over these here. Mobile OSs usually integrate, I want to say almost 99% of the time, use a touch screen, right, instead of a keyboard. While as desktops tend to stick to the keyboard. There are some iterations out there that provide a touchscreen monitor, but it's just a lot easier to use your keyboard and mouse for input. So that still remains the mainstay with desktops. Limited power supply by a rechargeable battery. Batteries have gotten a lot better. So, when the first mobile devices came out, you were lucky if you got like an hour or 2 out of them. Nowadays, you can have a phone moderately used for about 2 days, unless you're like running apps or running video or something like that. And even if you're running video, I think on my iPhone, I can probably watch a video for 4 or 5 hours straight. So batteries have gotten a lot better. limited RAM efficiency. So effectively, that means that we have limited memory, right? Whatever comes with the product, with the phone, the tablet, or that handheld device, is usually not expandable. And then now most mobile devices support cellular and Wi-Fi communication. Cellular means that you're getting your signal over a cellular provider out over the air, while Wi-Fi you're connected. You're connected to a private network or something that you're paying for, and then connectivity protocols other than Ethernet, right? So some of those protocols are LTE, 3G, things like that, data, and then regular cellular service. All right, any questions here, guys, on how your desktop and mobile OSs differ? All right, we're gonna move on. All right, the current OS market share. I love pie charts. They make me hungry. And in this case, Android is more hungry than me because Android dominates the market share. 70% of all mobile devices run on Android. And then its most competitive foe is iOS, which is Apple, and they have a share of about 28.44%. Look at Greg's favorite over here, Windows, 0.07, BlackBerry, 0.02, Symbian, 0.01, and then a mixture of other operating systems at 1.22. Those are operating systems that are being developed, or that might be specific to certain regions of the world, or that have their niche group of users. So pretty interesting. As you can see, the two big companies, Google and Apple, dominated. Okay. So now we're going to go over the current OSs that are used in smartphones and tablets. The most common OSs for smartphone and tablets, we just spoke about some of them, are iOS, which is for Apple. We see this in the iPhone and the iPads. Then we have Google Android, and we see this across a vast array of devices and manufacturers like Samsung, HTC. I think Amazon runs on Android, and then we got the Windows Phone OS, and then some other OSs down here like BlackBerry, Symbian, and HP WebOS, which I think used to be Palm, if I'm not mistaken, Bata, and Migo. Okay. All right, iOS. Anyone care to read this slide for us? Don't be shy now.
iOS. Apple iOS is only found on Apple products. iOS is built on the same foundation as Apple Desktop OS X, based on Unix, closed source softwares. Technicians do not have access to the source code. Developers must use the Software Development Kit (SDK) from Apple and register as Apple developers.
Thank you so much. So key points to take away from the slide is that iOS is Apple proprietary. It is closed source software, meaning that you developers and the public do not have access to the source code. And to become a developer for Apple, you have to get a SDK, also known as a software development kit, and you must register as an Apple developer. All right. The iOS is built on top of Unix, and Unix is an operating system that was developed by AT&T in the Bell Labs back in the first iteration was back in the 1960s. So they took something that existed and they built their operating system on top of that. Okay, now Unix sounds like something that we're going to speak about next, which is Linux. And Google Android actually is built on top of the Linux kernel. So don't try not to get Unix and Linux confused. Android is also written in Java, which is a programming language, and the mobile OS is maintained by the Open Handset Alliance. It is open source, and if you want to develop on Android, you have to share your code. It is one of the you have to do it because they want to maintain that ecosystem. They want the ecosystem to keep growing, and they want people to have access to the code. Yes, Kelly.
If you want access to free, you got to give up your stuff too. So whatever you develop, you have to share with the community. It's a community requirement.
And then the versions of Android are all named after a dessert in alphabetical order. Here are some examples: Jelly Bean, Kit Kat, Lollipop, Marshmallow, Nougat. I'm waiting for it to come back around for creme brulee, which is one of my favorite desserts.
And they do caramel or something like that the first time.
I don't know which one it was. Can't remember. But if they get creme brulee, I'll go back to Android. All right, Windows Phone operating system. This is proprietary to Microsoft, and it's based on it's built on top of the Windows New Technology kernel, which is the Windows NT kernel. And developers create their applications and upload them to the Windows Store, which is where the consumers can download them from. Like we mentioned before, Windows has been slowly decreasing in market share. It's very small percentage of the market now runs on Windows operating system, or the Windows Phone operating system. And I think one of the only manufacturers, or one of the few manufacturers who carry is like the Nokia, if I'm not mistaken. Some Nokia phones still run Windows OS, the Windows Phone OS. Does someone have a question? I think I heard someone ask something. I might be hearing things. All right. Here we go. Other mobile operating systems. BlackBerry OS. I don't know if you guys remember the Blackberries. They used to have like built-in keyboards. They were widely used in business around the time that I was in college. They started phasing out a little bit. The support for it was terminated in 2013. And they ran on RIM, which is Research in Motion, and it was almost immune to viruses. It was very hard to get viruses to attack the BlackBerry OS. Symbian is another mobile operating system, and it was terminated in 2012. The HP Web OS, formerly known as Palm OS, is available for tablets as well. BADA, B-A-D-A, was for Samsung, and it was terminated in 2014. Migo was replaced by Tinsen. And we see Tinsen here at the bottom. Tinsen is something that a lot of, a big percentage of smart TVs, tablets, and like in-car entertainment system use, and even the smart watches, the Samsung watches, use a version of Tinsen OS. All right, so yeah, here we see in 2019, approximately 21% of smart TVs sold ran on Tinsen.
Real quick, you got a question there, TW?
Oh, I'm sorry, go ahead, Daniel.
We're gonna have to know all of these for the test, right?
I don't think you need to know these other ones.
No, this is just kind of a history lesson.
Okay.
Yeah, this one slide's like a history lesson.
Yeah,
okay.
but
This also for the second test, right? Not the first one, right?
Right, this is 1002, yes. So the first three you do need to have knowledge of, because they're like the big players. But the ones over here is kind of like just, a good frame of reference, and like Kelly said, history, remembering what's going on there.
Thank you.
No problems. Any more questions?
They may, one caveat, they may ask, what are some other possible operating systems from the time? And so you may just need to be familiar with the names. So like if
Okay.
you see the name Bada, that should, let you know that that was a mobile operating system, or Migo, or Symbian. BlackBerry was pretty popular, so that was pretty easy to remember. But just if you see the name associated with a mobile operating system is all.
All right, real quick, guys. I want everyone to, if you have Apple, give me a green check mark, and if you have, if you have Android, give me the X, the red X, and if you have Windows, give me a crying face.
Perfect.
Awesome. So we actually kind of see the distribution here represented in our class, right? We see
Yep.
almost 80-20 Android versus Apple, and I don't see a single crying face. I'm waiting for Greg to put his crying face up. All right, Greg, I'll stop picking on you, brother. All right, guys, thank you so much for participating with that. What was that?
Ebony, do you mean the first 3 slides of the presentation total? All right, I'm going to pause the recording for 1 second.
All right, so Apple iOS versus Windows and versus Google Android. So these are some of the devices that run these OSs. So as you see, iOS is ran on the iPhone and the iPad. Windows devices have Nokia, specifically the Lumia backing them up. And then Android has a whole array. Some of the big players there are like the Samsung phones, all the Galaxies, Nexus, the LGs, Amazon devices, HTC, and Sony. All right, Apple iOS versus Windows versus Google and Android. These are some of the features pertaining to these operating systems. So these are all things that we're going to go over here in a little bit. So I'm going to go on to the next slide. All right, we kind of spoke about this earlier. Closed source software is also known as proprietary software or vendor specific. The software is licensed to others for use, but is kept within the control of the original publisher. And examples of this are iOS or the Windows Phone OS. Okay. Open source software is licensed to the developing community to be further developed, shared, and marketed. An example of this is Google Android. Right. Any questions here about open source and closed source? Okay. Application stores. Applications are apps. We all have our favorite apps. I think Kelly's favorite app is Candy Crush, even though he's never downloaded it. He just hears great things about it.
I even save archived versions of it.
I'm not gonna lie, I got pretty hooked on Candy Crush there for a while. But then they started asking for money, and I was like, I'm good.
In truth, though, DW, I don't think I've ever played it.
No, I know. You said that before, but you always mention, whenever we're talking about apps, you always mention Candy Crush.
Yeah, I know so many people who are addicted to that game.
All right. So applications for mobile devices are where all the exciting functionality comes from. There are thousands of developers creating apps, and they can be downloaded from online sources. All right. So the Google Play Store is where we're gonna get our apps on Androids. On Apple, we're gonna get it at the App Store, and it has this nice, graphical image. We're probably familiar with that. This is the one for Android. And then Windows Phone apps can be purchased and downloaded from the Windows Store. Technically, even if it's a free app, it's still called purchasing the app, right? So whenever you're interacting with the stores, you're technically purchasing all your apps, even if it is free. And also remember that if it is free, you're probably given something else up in return, something like data. Yeah, mostly data. So, you know, nothing is ever truly free. And even when you're not paying physical money for something, you know, those developers and those companies are getting something from you in return. Screen orientation. All right, we all love the feature when we're watching a video in portrait mode, and we flip it over horizontally to landscape mode. The video automatically expands, and this is achieved by using the gyroscope, which is a sensor that detects rotation around 3 axes, and those axes are called roll, pitch, and yaw. And what happens is when you rotate it, it detects if any of the edges on the mobile device was lifted or given a spin, or if it's laying flat. Okay, and then I always have a hard time with this word. Accelerometer. There we go. Accelerometer measures the change of velocity, which is a function of speed and direction. If you guys ever took physics, I'm having nightmares from my high school days right now. Velocity equals speed times direction. And it is one of the first kinetic sensors included in smartphones. So it's one of the first things that could sense movement on a mobile device. All right. Any questions about the accelerometer or the gyroscope? I said it pretty good that time. All right.
Dude, I do. Say it over 3 or 4 times in your head before you say it out loud.
Yeah, I said it like 5 times last night practicing it. So. All right, I'm gonna ask for some help for reading this screen. Let's just read the first 2 here, the types of touchscreen.
Types of touch screen. Hold on. Older devices had resistive touch screen that required periodically calibration of the screen so that the system knows exactly where it's being touched. Should I continue?
Yes, just the next one here, capacitive touchscreen.
Capacitive touch screen used in today's devices don't require any type of ongoing calibration.
Thank you so much, Marina.
You're welcome.
All right, so again, we've spoken about this, something that we've seen before and we should be pretty familiar with. So resistive touchscreens, those were like the first iterations of touchscreens, things like the Palm Pilots, that you kind of needed a stylus and you needed to sense like a firm pressure on the screen for it to work. It had to be calibrated, meaning that you had to tell the screen, hey, when I touch this, I want this part of the GUI to be interacted with. And then capacitive touchscreens are used in modern devices today, and they allow for gestures and multi-touch, which is something that almost all modern smartphones use today. These don't need ongoing calibration. I think we went over in the Kahoot, if your touchscreen, like let's say if your touchscreen on your iPhone isn't working, what you want to do is give it a restart by holding your power button down for 5 seconds and turning it back on, and that'll usually free it up, and it'll automatically calibrate that capacitive touchscreen for you on boot up. All right. Some issues that we can come across is our calibration errors, and this is when an item is touched on the screen when you're touching something else. So if you're touching the bottom right of the corner and it's touching something on the middle of the screen, that's when you know you have a calibration error. And we just spoke about how to recalibrate as respective to the types of touchscreen. So if you have a resistive touchscreen, there'll be a built-in tool where you go to recalibrate, and then we just said capacitive touchscreens, you would restart your device and it would automatically recalibrate on the next boot up. Any questions about calibration here or auto calibration?
I have
Go
a
ahead,
question,
Cindy.
right? So you know how I guess like mostly with Androids they have like you could use the touch screen, but you could also use like the hard like stylus. Is this same calibration or is it the resistant?
Yeah, like the more modern ones, the modern ones. I'm assuming you're talking about like the Galaxy, the S and the S phones and stuff like that, right?
Yeah, I in my head it's a tablet, but yeah.
Yes. So they all use capacitive touchscreens at this point.
Okay.
Yeah. It's just, you know, even those styluses for those capacitive touchscreens, they have a little, what is it at the end that they have, Kelly? For they transmit a little bit of like electric current, I guess.
Yeah, they're allowed to. Yeah, they're allowed to transmit the charge or whatever.
Right.
And but they do have some resistive capabilities. Like if you notice, more recent touchscreens and stuff like that are able to register pressure, so it can tell a soft touch versus a harder touch. Especially if you're using like some of the art programs, they'll give you like thinner lines with softer touches. As you apply more pressure, it gives you broader strokes and stuff like that. So they're adding some resistive capabilities to them, but they are still capacitive.
Thank you. Makes sense.
So they still fall under the capacitive tree, is what you're saying.
Yes.
Okay.
Awesome. Thank you, Kelly. And good question, Daniel.
Yeah, I agree.
All right, positioning and geolocation. So geolocation provides the relative and absolute positioning of the device from the viewpoint of the planet and space. And the two technologies that are used by smartphones and mobile devices to accomplish this are the magnetometer and the GPS or global positioning system. Okay, so if you ever ran the compass app on your phones, you notice that it acts like a real compass, right? It points to magnetic north, meaning the North Pole. And the global positioning system detects the absolute positioning in respect to the man-made latitude and longitude markings through triangulation. It uses 3 satellites at fixed distances above the Earth's surface. And when satellites are completely unavailable, cellular or Wi-Fi can be used to give a slightly less accurate position. Okay.
And as we learned earlier today, the magnetometer is going to have problems in about 2 years.
Well, it'll start pointing to the south instead of north, no?
Okay. Well, they'll essentially build in a correct for it. I mean, it's been wobbling for years where it's not exactly where it was, so it's been wobbling for a while.
So they're awesome. Thanks, Kelly. Any questions about the GPS system or the magnetometer?
Magnetometer.
Magnetometer. Thank you.
There you go. I think of it like magnetometer.
Yeah, I just want to call it magneto. The
There you
magneto.
go. Yeah, that would actually work.
Magnetometer. There you go. All right. Geo tracking and geotagging. So geo tracking is prevalent in both iOS and Android devices, and it records the location of the device periodically and sends this info to a central location. Very controversial. We could get into big discussions over this. But yes, just be aware that your devices do geo-track you. And then there's geotagging, which uses similar information to add location information to various forms of media, such as photos taken with the devices and messages sent to the devices. It is very common in social media and easy to disable. So yeah, if you guys have Instagram or Facebook, you can take a picture and it's like tag where you're at. I remember when Facebook first came out with that, and I was like out tagging everywhere, and then I got into trouble because I had told someone that I was at a certain place, and then I posted a picture and I was not at the place that I said I was at. So just want to be careful with your social media and what you allow to be geotagged. Oscar laughs at my perils. Wi-Fi calling. All right, this is a feature that I love to use, especially when I'm home. I can sync up to my Wi-Fi, and I can speak over the Wi-Fi signals instead of the cellular signals, because I have terrible cellular signal in my building. So it's very similar to VoIP, but it's wireless. You know, voice over IP is what VoIP stands for. Have we had a chance to go over that yet, guys? Do you guys remember VoIP?
I don't think we've gone over that one just yet.
Okay. So voice over IP basically means that you could use your internet provider as a medium to use a telephone system, right? So you can, if you have one of those all-in-one packages like cable, internet, and phone, this is what you're using, right? Because it's not going over POTS anymore. It's going over that cable connection, and you can do everything through that. Your internet, your telephone, your voice services, and your TV services. So we'll get more into VoIP later on in the cohort. All right.
Wi-Fi calling, sorry, Wi-Fi calling as in like FaceTime, or like you download an app and call, or like regular just calling on Wi-Fi?
So thank you, Danny. So FaceTime does work over Wi-Fi calling. So does WhatsApp. So do other things, but you can, there should be a setting in your mobile device where you can go to enable Wi-Fi calling. And what this means is when you're connected to a Wi-Fi network, instead of your call being routed through the cellular connection, it'll be routed over the Wi-Fi connection. And like you were saying, it can encompass different apps to do that. It can do it over the actually phone app. If I'm speaking about iOS, they can do it over FaceTime. They could do it over WhatsApp. They could do it over Messenger. You know, all these things that you use to communicate, voice communications, you can do Wi-Fi calling.
We can do regular calling too with the Wi-Fi call, isn't it?
Yes, you can. That's what I mean by the regular phone function. So yes. And then it uses an 802.11 connection, and that's something that we'll also get more familiar with as the cohort goes on. 802.11 is just a wireless standard. It's pretty much what the standard for Wi-Fi's for wireless data. And when it's functioning properly, you won't even notice that you switch from your cell network to your Wi-Fi network. For me, I notice because I get better service. So like if I'm in the hallway and I'm not yet connected to my Wi-Fi, as soon as I get it in my apartment in range of my Wi-Fi, that call just gets better. Like I get a stronger signal. It tends to drop less often, and I'm just a pretty happy camper at that point. Do we have any questions about this here, guys? All right, the launcher or the GUI. A launcher is a screen. It is a screen with icons like the desktop PC. It is a program that locates and starts another program. Launchers are GUI based. Real quick, guys, in chat, just what's GUI?
Graphical user interface.
Yeah, awesome. And that's pretty much means, that it's not command based. You're not having to type out your commands. It has icons and you can interact with it. Nice little pictures usually, right? And then so the launchers are GUI based, and they provide the user with additional items in the menus, extra screens, and extra functionalities. Androids allow you to personalize the launcher. You can have different widgets. You can set which page you want to be your home page. Apple's a little bit more strict. They want their users to know and be familiar with the iOS and know that that's what they're on, right? So it's very very strict almost with that customization. Virtual assistants. All right, so these different OSs have different virtual assistants to help you in your tasks, make things easier for you. For example, when I want to look up, when I want to call a takeout restaurant that I don't have the number saved for, or that if my hands are busy, I go Siri, call Venice Pizzeria, or Siri, call Burger Time, you know, and Siri goes ahead and does it for me. You know, on that note, iOS is personal assistant is called Siri, and it responds to voice requests and commands. Android supports multiple virtual assistants with voice recognition and voice actions. The default one is Google Now. Windows Phone and Windows in general use Cortana as the intelligent personal assistant. And it was created by Microsoft for Windows 10 Mobile and Windows Phone 8.1. And it's also available in, like I said, in regular Windows OSs for desktop and laptops. Any questions about the virtual assistants here, guys?
Hey, DW, quick question. If this is just a test question, I guess. If something is no longer the case, right? But it states it here, do we still use the older information, or we use updated information? For example, Google Now has been replaced by Google Assistant. Do we still look for Google, or well, it's multiple choice, I guess. But how do we handle stuff like that that's changed since it was written?
So in those instances, when the test was written, it used Google Now, so you would have to be familiar with that. Even if it got updated to something else, they will use this. Is
Okay.
that correct, Kelly? In me saying that?
What was the original question?
He's saying,
So, yeah, if something has changed since these slides have been made, possibly the test, original test, do they update those? For example, like Google Now no longer exists; it's Google Assistant, right?
Yeah, or Hey Google or whatever. Yeah.
Mhm.
Well, the thing is they wouldn't give you both in the same answer. So you get what I'm saying?
Okay.
what he's saying is, Greg, is like it'll be like the answer will have Google Now, iOS, Siri or Windows Cortana. It won't have Google Now and Google Access as answers.
This is
And
more
then
of a general. This is not more of a general question still, because I was just kind of curious. Do they update anything, whenever something is changed? That's kind of the question,
Depends on how major the change is.
Oh, okay, gotcha. All
If
right.
it's something minor, no. If
All
it's
right,
like industry changing, yes. If it's minor things, they just let those kind of add up a little bit and then change them when they move on to the next version.
All right, understood.
So it's like what I'm noticing so far with the 10.01 to 11.01 change is mostly linguistic changes, like they're changing the names of things to update the names.
Okay. Yeah, this would be one of those things too. Yeah.
Yep.
It's been a long time. Okay.
Thank you. Good question, Greg, and thank you for your help on that cover. All right. Development kits, also known as SDK or APK. So SDK software development kits or ADK application development kits are sets of tools provided to third-party developers to assist in the development of apps that will run on Apple or Android OSs. All right. Windows Mobile can have apps developed on Windows 8.1 desktop using Visual Studio. One of the main causes of Windows phones not gaining more popularity has been not enough development of apps for their system. All right, so in the applications for Android can be created on Windows, Mac OS, Linux, and by using the Android Software Developers Kit or Android Studio. Once the apps are created, they are distributed in a standard format called the Android Application Package or APK. Okay. Do you have any questions about this here, guys?
Okay, so from the last reading, apps are developed in SDK and then distributed in APK. Oh, okay, yeah. Okay, so SDK and ADK. Oh.
Yes. So these are the kits that they give out, right? SDK, software development kits, or ADK, application development kits. And then for Android specifically, it is distributed in a APK, which is the Android application package, and it's a standard format. Yeah. Did that help you out there?
Thank you. Yeah.
Awesome. Any other questions here, guys? Okay. Emergency notification. So wireless emergency alerts are sent out by the authorized government alerting authorities and delivered through a provider. These may include extreme weather warnings, local emergency evacuation or immediate action, Amber alerts, or presidential alerts during a national emergency. So I'm sure we've all experienced this, where we get that high-pitched wail almost when there's an Amber alert, or if there's like severe weather. Like I get them for flooding. I'm sure Kelly, you get them for hurricanes. We get them for like
it's usually 3 a.m.
Yeah, wow. Yeah, we get them at all times, and sometimes it's other things like Amber alerts, where like there's a missing child, or maybe there's a
Silver
gunman.
alert.
Say that again.
Silver alerts.
What's that? Silver alert?
It's elderly person is missing.
Oh yeah, I've gotten one of those too before. And then there's also, alerts during national emergency. I imagine, if there was, God forbid we got into, some kind of conflict with an outside nation, and there was like incoming missiles or something. I'm sure that would go over, the emergency notification infrastructures built.
Well, I mean, it also could be for, massive like flood damage or things like that. I mean, there's a multitude of reasons why they could use it.
I know FEMA uses it.
Yep, FEMA.
Yeah. One of my good buddies actually worked on the emergency alerts for FEMA, so pretty cool things going on there. Any questions about emergency notification here, guys? All right. Almost at the end here. Mobile payment service. So phones can be used as wireless mobile payment systems by attaching a device that accepts credit cards from payments through a specialized program. The most popular is Square. One of my favorite restaurants, Venice, when I go in to pay with my credit card, it's literally attached to his iPhone. He just swipes it, and that, I also think it's Square because I see the little symbol for Square. There are other ways that you can set that up as well. Near field chip, right? Is one of those. Near field communication, NFC is the basically tap and go feature. And that was actually recently integrated to the public transportation system here in New York. For my fellow New Yorkers, if you don't have your Metro card, you just pull out your iPhone or your Galaxy and you tap it to the turnstile. It reads whatever credit card you got established with that, or whatever account you got established with that, like PayPal or Cash App or Venmo, and you just tap it and then boom, you're good. You don't have to go to the line with 15, 25 people to get a Metro card anymore. If you're in a rush, you can just do that. And they've actually even made more improvements to it, where now it keeps track of how many times you use it in a month. And based on how many times you use it, it gives you that discounted price that you would have gotten for like a monthly pass or a weekly pass, which is pretty cool. Big fan of that. And here it is at the bottom. Google Pay for Android uses NFC, near field communication, which performs contactless payments. Apple Pay for iOS uses the same technology. And Samsung Pay started with the Galaxy S6, works with NFC terminals and the older magnetic strip readers. Any question about the wireless mobile payment systems or NFC or Apple Pay or Google Pay? Is this something that we have used? Show of hands, raise your hands if you use NFC to pay for something. All right, okay, cool. Yeah, I always used to be pissed because sometimes I would run out. Oh, I'm sorry, go ahead, Joyce. Oh, you were raising your hand to tell me that you, oh, never mind. Okay, cool. So, okay, back to my anecdote. So, yeah, I am notorious for forgetting my wallet. And, you know, when this came out a couple of years ago, when Apple Pay, I wouldn't have my wallet, and I would like be in the drive-through, like waiting for 30 minutes, and I get there and I'm like, hey, I'm gonna pay with my phone, and they're like, no, our reader isn't working. I'm like, come on. And I would be so upset, you know, because I knew I didn't have my wallet with me, but I had my phone and I thought it'd be okay to use it like that. And then their reader is down. So no Happy Meals for me. All right. So now we should be able to describe at a high level the similarities and differences between mobile operating systems and other operating systems, and compare and contrast the most widely mobile operating systems like Android, iOS, and Windows, including their most common functions and features. So with that brings us to the end. Is there any questions here, guys? Anything you'd like me to go over again? Do we feel comfortable with this information? Are we ready for a 20-question quiz on it?
Yes.
I'm just kidding with you. That's not going to happen. But yeah, I'd like to thank you again for allowing me to lead you through T-Session 40, the introduction to mobile operating systems. You know, please return your seats to their upright position and have a great day.